Waidsum Academy. Today we'll be looking at Maths Paper 2, May, June 2020. Okay, we're looking at Maths Paper 2, 1, May, June 2020. Okay, without much ado, let's begin. And in this paper, there are some assumptions we have to bear in mind. One of it is the pi. The value of pi will be 3.142. That will be using. And the total marks for this paper is 70 marks. Okay, so let's go to our first question. Our first question says that rectangle A measures 3 centimeter by 8 centimeter. Say rectangle A measures, okay, let's make it brighter. Rectangle A measures 3 centimeter by 8 centimeter. So we take a look at this rectangle. We can see the length. The length is 8 centimeter and the width is 3 centimeter. So this whole space is the area. This whole space is the area. So if we want to find the area, we just say length times width, right? However, that's not what the question wants or demands from us. It says 5 rectangles congruent to A are joined to make the shape. Are joined to make a shape. So there are 5 of these rectangles that are be joined together to make this shape. 1, 2, 3, 4, 5. So they are all congruent to A, meaning they are same as A. They are same as A. They are 5. So the whole 5 are joined together to make the shape that is given. Now, the question says, work out the perimeter of this shape. Work out the perimeter of this shape. Okay. Now, this is the big deal. You have to look very carefully and assign the length of each side before you're able to do this. You assign the length of each side in order to do this. We already know the length of the rectangle is 8 centimeters. So we make this place 8 centimeters. We make here 8 centimeters. We know the width is 3 centimeters. So we make here 3 centimeters. However, you know this broken line, it means there is no line here. So we know the width is 3 centimeters. And this broken line is the width of this rectangle here, the horizontal rectangle here. So if you take 3 out of 8, you know the whole length is 8. If you take 3 out of 8, it's remaining what? 5. So it's remaining 5. So 6 here to here is equal to here, from here to here, is same as here to here. So it means 5 divided by 2, 2.5. So here to here is 2.5, here to here is 2.5. This remaining small broken line is 3 centimeters. Why? Because it's same as this one, same as this place. It's same as this place, 3 centimeters. So the whole line, the whole length is 8. If you take out 3 centimeters, 2.5 centimeters and 2.5 centimeters makes up the 5 that is remaining if you take out 3 centimeters from here. So here you already know it's 8. Here you know it's 2.5. Here you know it's 3. Okay, here is 2.5. Here is 3. Although we don't need to put any number here because it's broken line, meaning it's a free express. Okay, here is 2.5. Here is 8. So we assign everywhere, and then we calculate the area. Work out the perimeter of each side. So we can start with the one with 8. Look at the one with 8 centimeters. 8 centimeters here. How many 8 centimeters? 2, 3, 4, 5, 6. We can do it like that, or you start to add everything one by one. You can say 8 plus 3 plus 2.5 plus 8 plus 2.5 plus 3 plus 2.5 plus 8 plus 2.5 plus 3 plus 8 plus 3 plus 2.5 plus 8 plus 2.5 plus 3 plus 2.5 plus 8 plus 2.5 plus 3. And then you get the total. You can do like that. You get the total. It's like, because perimeter is the total distance around an object. Perimeter is the total distance around the object. You can do it like that. Or I just consider the lengths with 8 centimeters. Or I count them, I multiply by that number. 1, 2, 3, 4, 5, 6. So there are 6 of them. So I will say 8 centimeters times 6. I'll get 48 centimeters. Okay. Then the next one, I'll count the one with 2.5. How many 2.5 do we have? 1, 2, 3, 4, 5, 6, 7, 8. So I'll say 2.5 multiplied by 8. I'll get 20 centimeters. Then remaining 3 centimeters. I'll count the 3 centimeters. 3, 4, 1, 2, 3, 4, 5, 6. There are 6 of them. So I'll say 3 times 6, I get 18. So perimeter is for me to add all of them together. 48 plus 20 plus 80, I get 86 centimeters. So you get 2 marks for doing this. Okay? You get 86 centimeters, you get 2 marks for doing this. Is that okay? So, like I said, you don't have to count only 8, count only 2.5. You can just, after you finish labeling them, after you finish designating them, you just add, you start from the beginning. You say 8 centimeter plus 3 centimeter plus 2.5 plus 8 plus 2.5 plus, you start adding everywhere, step by step, till you reach where you started. And then you still get the same answer. You still get the same 80, you still get the same value, okay, as 86. Now let's go to the second question. Let's go to the second question. Question 2 is find the highest odd number that is a factor of 60 and at the same time a factor of 90. The highest odd number that is a factor of 60 and a factor of, so what we do, we list out the factors of 60, we list out the factors of 90. Remember, this question is not asking us for the LCM. The question is not asking us for the LCM. It's only asking us to find the highest odd number that is a factor of 60 and at the same time a factor of 90, the highest one. So it's not the only factor, but it's the highest odd one. Other factors that you may find that are even number, like 30, may not be suitable for this question. They say the highest odd. So you see the bolded odd. They made it bold. So they're telling you, take note of this. We are looking for the odd number. So the factors of 60 are 1, 2, 3, 4, numbers that can go into 60 without a remainder. We started from 1. 1, 2 can divide 60 without a remainder. 3 can divide 60 without a remainder. 4 can divide 60 without a remainder. 5 can divide 60 without a remainder. 6 can go into 60 without a remainder. 10 can go into 60. 12 can go. 15 can go. 20 can go. 30 can go. And then 60. After half of the number, the next one is the number itself. After half of the number, the next one is the number itself. Now we write down the factors of 90. 1 can go into 90 without a remainder. 2 can go into 90. 3 can go into 90. 9 can go into 90. 6 can go, right? Do you skip 6? Probably, maybe 6 can go. But even if it can go, it's a even number, so it's not an odd number. So they are telling us the highest odd one. So 9 can go into 60. 10 can go into, 9 can go into 90. 10 can go into 90. 15 can go into 90. 30 can go into 90. 45 can go into 90, which is half of the number. After half of the number, the next factor is the number itself. Now, if you take a look, 1 and 1 is a factor, but they say the highest. So instead of saying 1 and 1, because it's not the highest odd number, so we cannot choose this one. This 2 and 2 is a common factor, but is even number. They say we should consider only the odd number. 3 is odd number. 3 can go, but it's not the highest. Remember, they use the word highest. So we are looking for the highest odd number. Okay, we see 5 here, there's no 5 here. We see 6 is not even odd number. 10 is not odd number. 12 is not odd number. You see 50 here, and there we go to look for 15. Okay, we select this first, but we see whether there's any higher number that is odd number. 30 is even number. 45 is here, but there's no 45 in 60 as a factor of 60. So we cannot choose 45. So the highest odd number factor common to 60 and 90 is 15. So it's 15. We do that, we move to question number 3. Now question number 3 is Mrs. Salama gives her class 2 mathematics tests. The scatter diagrams, okay, this is a pure grade 11 question. The scatter diagram, or probably grade 9, grade 11. The scatter diagram shows information about the marks each student scored. Now let's take a look at the diagram. This test 2, okay, the vertical one is test 2, the horizontal one is test 1. Remember, this line was not drawn, we drew this line, okay? They just put the scatter diagram only, or this mark, okay? Test 1 and test 2. Now let's see the questions that come over this. It says write down the highest marks scored on test 1. Now here's test 1. Let's see the highest score. This one, right? You trace it down to test 1. This is the highest mark. To the right. To the right. This is the rightmost. This is the rightmost score. So you trace it down to test 1. You trace this one down to test 1 and you read the value. You see the value is 66. The value is 66. So our answer to this one is 66. Okay? The second one is a write down the type of correlation shown in the scatter diagram. Okay, if you've done scatter diagram, you can see they are all skewed towards a positive gradient. They are all skewed towards positive gradient. So we call this one positive correlation. We call this one positive correlation. We call this type positive correlation. But it's another issue whether you should call it strong positive or weak positive. But we just call it positive correlation for easy ability. Now let's go to the C part of the question. It says draw a line of best fit on the scatter diagram. Draw a line of best fit on the scatter diagram. Now, that's how you need at least minimum of 3 points to form a line of best fit. So you draw your line, just like the way we drew this line, to pass through this point, this point, this point, and this point. We had, I think exactly we got about 4 of them to enter our line. So you can select, you can draw your line any way you want it, but you must get minimum of 3 points to form your line of best fit. So we have done that, and then when you draw the line of best fit, you get the desired mark, which is a mark for drawing that. Okay, now the next question says, Hamish scored a mark of 40 on test 1. He was upset for test 2. He scored a mark of 40 on test 1 and he was upset on test 2. Use your line of best fit to find an estimate for his marks on test 2. Okay, you go to trace what he got, right? The 40 he got on test 1. Trace it to your line of best fit. Let's estimate what he would have gotten for test 1. It's just an estimate. What he would have gotten for test 2. It's just an estimate. It's just an estimate. Okay? Remember, he didn't do test 2. He was upset. He only did test 1. But they are telling you to estimate with your line of best fit. So what are you going to do? You go to what he got in test 1. He scored 40. Test 1, this horizontal one is test 1. And the vertical one is test 2. You go to your test 1, you got 40. Be tracing 40 to your line of best fit. You trace it to the line of best fit, and then you trace it to the test 2 side column. Trace it to the test 2 side, and we got 48. Meaning if you had done test 2 approximately on an estimate, you would have gotten 48. Based on what you got in test 1, you would have gotten 48. Okay, so that's that for that question. Now we move on to the next question. Question number 4. Okay, question number 4 says a bar cut. This probability question. Question number 4 is a probability question. It says a bar contains blue, red, yellow, and green balls only. A bar contains blue, that's 4 colors, blue, red, yellow, and green balls only. A ball is taken from the bag at random. Now the table shows some information about the probabilities. Okay, now we have the column, we have the row for color, we have the row for probability. So you can see for the blue, red, yellow, and green, the various probability have been given, except for yellow. Now the first question says complete the table, meaning find the probability of yellow. So since they've given you the probability of the rest, they didn't give you for yellow. The sum of all probabilities must be equal to 1. That's the rule. The sum of all probabilities must be equal to 1. Sum of probability equal to 1. Probability sum equal to 1. So when you sum probability, you get 1. Okay? So when you sum probability, you get 1. So which means I will add this plus this plus this. I'll add this 3 that is given. The total, I will subtract it away from 1. To find yellow, I will say the blue plus red. The blue is 0.15, the red is 0.2, and the green is 0.43. So I will add both to get all three together. 0.15 plus 0.2 plus 0.43. 0.15 for blue, 0.2 for red, and 0.43 for green. I'll add all of them together. I'll subtract the answer I get away from 1. I'll take the answer away from 1, meaning 1 minus the total I get here. 1 minus the total I get here. So when you subtract 1, when you say 1 minus the total here, you get 0.22. So yellow will be 0.22. Yellow probability will be 0.22. Will be 0.22. Will be 0.22. So that will be the probability for this one. Is that okay? That will be the probability for this one. Now let's move to the B part of the question. So you get 2 marks. If you're able to do this, you get 2 marks. If you're able to do this, you get 2 marks. Now let's go to the B part of the question. Say, Abdul takes a ball at random and replaces it in the bag. Abdul takes a ball at random and replaces it in the bag. He does this 200 times. He does this 200 times. Find how many times he expects to take a red ball. Okay, we go to, if they say find how many times he expects to take a red ball, you're going to take the probability of red multiplied by the 200 times Abdul does that. You're going to take, if they say find how many times he expects to take a blue ball, you take the probability of blue, you use it to multiply the 200. So it depends on which color they mention. If they say find how many times he expects to take the yellow, you say 0.22 times 200 times that he does that. If they ask you find how many times he expects to pick a green color or a green whatever, a green ball, you take the probability of green, which is 0.43, multiplied by the number of times he does that, which is 200. So you say 0.43 times 200. In this case, for this exam, for this paper, they were talking about what? They were talking about red. They were talking about red. So we're going to use the probability of red to multiply the 200 times. He does that. So you say the number of time equals to PR, probability of red, times number of trial. Probability of red times the number of trial. And remember from the table, the probability of red is 0.2. The probability of red is what? 0.2. So we say 0.2 multiplied by 200, that gives us 40. That gives us 40. So number of trial is 40. Now we go to the next question, question number 5. Question number 5 is a sequence question. Question number 5 is sequence. Now let's take a look. We say the nth term of a sequence is 16 minus 8n. The nth term of a sequence is 60 minus. So they give you the nth term. In many cases, they ask you to calculate the nth term. Probably they give you the first term and they give you the common difference. They probably ask you to calculate the nth term. In this question, they give you the nth term. Let's know or find out what they want us to find. Now, it says find the largest number in this sequence. Find the largest number in this sequence. Okay, the largest number will be when n equal to 1, right? The largest number is obtained when n equal to 1. Why? Because you are going to subtract from 60. So if you make n 2 times 60, 2 times 8 will be 60. If you subtract 60 from 60, it's going to be a smaller number. It's going to be a smaller number. If you say n is 3, 3 times 8, you get 24. If you subtract 24 from 60, it's going to be way smaller number. So the only way is when we make n to be 1. Okay? We don't start from 0 anyway. So n has to be 1. So 1 times 8, 8. 60 minus 8, you have to say the n term equals to 60 minus 8n. So n term equals to 60 minus 8 times 1 because n equal to 1. So 60 minus 8, 8 times 1 is 8, 60 minus 8 equals to 52. So the largest number will be 52 in the sequence. Now let's go to the B part of the question. The B part of the question says, here are first 5 terms of different sequence. This is a different one now. This sequence is different from the previous sequence. So the n term is not going to apply. The n term of that previous sequence is not going to apply in this question. Here, we'll be given a sequence. The first term is 12. The next term is 90. The next one is the following. The third one is 26. The fourth one is 33. And the fifth one is 40. You can see the pattern. The first term, A is equal to 12. The common difference, you can see 19 minus 12, you get 7. 19 minus 12, you get 7. And you have to double check here also. By saying 26 minus 19, you also get 7. 33 minus 26, 33 minus 26, we also get 7. Is that okay? So since that is the case, then we can unarguably assume that say that the common difference is 7. Then we use the n-term sequence, the formula for calculating the n-term of a sequence, of arithmetic sequence, since this is an arithmetic sequence. So we say n-term equals to the first term plus n minus 1, you put it in a bracket, times common difference. N minus times common difference. I know you can use position to term formula way to solve this by drawing the position 1, position 2, position 3, position 4, and then you say you find the difference. So that's another way. But the formula way is easier. The formula way is easier. So once you write the formula, A is first term, N is number of term, D is the common difference. So once you do that, you substitute these two values here. How? You substitute 12 for first term, you put it here, in place of A, plus, then you open a bracket, N minus 1 times the common difference, which is 7. Remember, we don't know the number of term. They want us to find an expression for the n term of the sequence. So we are looking for the n term of the sequence. So they will not tell you the number of term. So n term equal to 12 plus, you now use this 7 outside to multiply the bracket. You expand this bracket by saying 7 times n, you get 7n. 7 times minus 1, you get minus 7. So you get 12 plus 7n minus 7. Now you collect like terms, which means that 12 minus 7, you get 5. 12, this 7n, you write it first. You write the 7n first, then you say 12 minus 7, you get 5. So this will become our n term of the sequence. You get 2 marks for if you're able to do this. Now let's move to the next question. Question number 6. Let's go to, this is geometry. Let's go to question number 6. Now, you see, we extended this line. It was just a quadrilateral that was drawn for us. You may say it's a, excuse me, you may say it's a trapezium, which it is, actually, it's a trapezium. And you can see these two lines are parallel to each other. These two lines are parallel. So we extended it. Okay. Now, if you have two lines, a line joining them, this angle is alternate to this angle. Okay, the angle here, this one, this angle, this whole angle, wait left. Okay, this whole angle is alternate to this angle on this other side. Since the two lines are parallel, it's alternate. Okay, it's alternate. You can as well say this one is alternate. The one here, inside here, is alternate to this way also. In that case, we change the color to remove confusion. You can say this one inside here, this one inside here is alternate to the one outside here, alternate angle. Okay, you know alternate angles are equal. So I can as well write here 97 minus 3x. I can write it here, the one here, this value here. Now let's see what the question wants from us. Okay, let's read what the question wants. It says work out the value of x. The question just says work out the value of x. So which makes it easy for us. Okay, you know this angle plus this angle, this yellow and this green, if you add them together, forms an angle on a straight line. Right? Sum of angle on a straight line. You can see this is a straight line. Sum of angle on a straight line. Sum of angle on a straight line equal to 180. Sum of angle on a straight line sums up to 180 degree. So that's what we're going to do. Sum of angle on a straight line equal to 180. Okay, it's cut here, but that's what it is. 180, okay. So that's what we're going to do. So we're going to add this angle 69 plus 5x plus 97 minus 3x equal to 180. So we're going to write them out. We're going to write them out. 69 plus 5x, which is this one. You can see it here. 69 plus 5x plus this one, 97 plus 97 minus 3x equal to 180. What did we just do? We said the sum of angle on a straight line adds up to 180 degree. The sum of angle on a straight line sums up or add up to 180 degree. Okay, so then the rest is just to add the like terms together. The ones that have x, we add them together. 5x has x, 3x has x, minus 3x has x. So we deal with this together, which means 5x minus 3x. 5x minus 3x will give us 2x. That's how we got this 2x. 5x minus 3x will give us this 2x. Now we add the numbers together. Let's add the numbers together. The numbers 69 plus 97. 69 plus 97 will give us 166. Will give us 166. Then we equate to 180. We equate to 180. So we move this 166 to the right side. When this plus 166 go to the right, remember this plus goes with this 166. When it goes to the right side, it's going to be subtraction. So it becomes 2x equals to 180 minus 166. 2x equal to 14. And then because we're looking for x, we divide both sides by 2. Okay, why we divide it by 2? Because here is multiplication. 2 and x is a multiplication. So to find the x, you have to divide, not subtract 2 from this side. You divide here by 2, you divide here by 2. Both sides by 2, you get 7. So x equal to 7. You get 3 marks if you're able to do this. You get 3 marks if you are able to do this. Now let's go to question 7. Let's go to question 7. Now we'll be given a big number, 234, and we'll be given the product of its prime factorization. We'll be given the product of its prime factorization. This means 2 times 3 raised to the power 2 times 13. Okay? Now take a look at this one, a bigger number, 1872 has been given, the prime factorization has been given, 2 to the power of 4 times 3 to the power of 2 times 13. And 234 times 1872 gives us 438,048. So we get this huge number. If you multiply these two numbers together, we get this. So now use this information to write 438,048 as a product of its prime factor. This is so easy. What we just going to take the whole of this, remember, and the whole of this, and we join the ones that are similar. We just going to take the whole of this. Here we already have 2 to the power of 5, 2 to the power of 4, and here we have only 2 to the power of 1. Ordinary 2 means 2 to the power of 1. Ordinary 2 means what? 2 to the power of 1. Ordinary 2 means 2 to the power of 1. So what it means, 2 to the power of 1 multiplied by 2 to the power of 4. It will be 2 to the power of 5. That's how we got 2 to the power of 5. In case you are wondering why. Because this, this number multiplied by this number gave this huge number. Now, since they're asking us to find the product of the prime factors, you just take the prime factor of this number and the prime factors of this number. And then it will give you the prime factor of the whole number. So the numbers that are same, you join them together with indices. 2 to the power of 1 times 2 to the power of 4 will give you 2 to the power of 5. Now here we have 3 to the power of 2, and here we also have 3 to the power of 2. So you are multiplying them. In indices, 3 to the power of 2 times 3 to the power of 2, we get 3 to the power of 4. That's how we got this 3 to the power of 4. And then here we have 13 to the power of 1. Even if we don't write 1 as a power, it means it's there. 13 to the power of 1 times 13 to the power of 1. That's how we got 13 to the power of 2 here. Finish. You don't need to multiply the answer. You just write them out. 2 to the power of 5 times 3 to the power of 4 times 13 to the power of 2. You do that, you get this. It's just 1 mark telling you that you don't need to do anything. You just bring what is here and here. You bring them down. Okay, so let's move to the next question. Question number 8. We move to question number 8. Okay, question number 8 is just a simple fraction. Primary school can do this. Okay, primary school, for real. A good grade 5 student or a good grade 6 student can do fraction. Now, you say without using calculator, you see what they said? Don't use calculator. Remember paper 2 at this time, we are still using calculator. Paper 2 now, you are not allowed to use calculator. The questions are still similar, but you just leave your answer whether in fraction. You don't necessarily have to leave your answer in decimal. Okay. Now, without using calculator, work out 2 whole number 1 over 3 minus 7 over 8, all put in a bracket, multiply by 6 over 25. So what we do bracket first because of big mass or board mass. Okay, depending which one you were taught. Okay, because of board mass, you're going to do the bracket first. Bracket comes first. So you treat the bracket first. That's what we wrote here. So we're going to treat this bracket. So I'm going to change this one to a proper fraction first. You know it's a mixed number. So we're going to change it to a proper fraction. So we solve the bracket first. That's what we wrote. So the first thing we do is to change this to a proper fraction by saying 3 times 2, we get 6, plus 1, we get 7. It becomes 7 over 3. It becomes 7 over 3. This is the fraction. 3 times 2, we go again. 3 times 2, that's 6, plus 1, we get 7. So the fraction becomes 7 over this 3, 7 over 3. Minus 7 over 8. So because the denominator are different, and one is not half of the other one, so what we do, we take this denominator here, because we want to have the same denominator. In order to have the same denominator, you take the denominator here to multiply the whole of this. That's why I put a bracket, I multiply it with 8. Where did the 8 come from? It came from this denominator, So you take this denominator here to multiply the whole of this, and you take this denominator of 3 to multiply the whole of this one. That's how this 3 came here. So let's do the multiplication. 8 times 7, we get 56. You must be good with the multiplication table. 8 times 7, we get 56. And then 8 times 3, we get 24. You get 24 here. So it becomes 56 over 24 for this first part. Minus, now let's do this one. 3 times 7, we get 21. 3 times 7, we get 21. And then 3 times 8, we get 24. That's how we got 21 over 24 here. Now you can see the denominator are same now. Why we did this, why we did the operation we just did, why we took this denominator to multiply the whole of this, and we took this denominator to multiply the whole of this, is for singular reason, because we want the denominator to be same. Now that the denominator are same, you cannot subtract the numerators. You can subtract the numerators. So 56 minus 21, you get 35 over 24. You just take one of these as your denominator, finish. Once they are same, you write only one of them. Become 35 over 24. Okay? Now, we go to stage 2. Remember, stage 1 was just to solve the fraction, the bracket. Now that we solved the bracket, we go to the answer we got, which is 35 over 24. We go to use it to multiply this 6 over 25. So we bring the 35 over 24, we bring it down here. The answer we got, remember the answer we got. We bring it down here. Multiply by 6 over 25. Multiply by 6 over 25. So now here it's up to you. But for me, it's easy for us to just begin to see what can cancel. You know, when you have two fractions and there's multiplication sign between them, you can begin to cancel each other based on which number can go to which number. 25, 5 can divide 25. 5 divide 25, you get 5. 35 divided by 5, you get 7. Now, for this one, 6 and 24, 6 can divide 6, you get 1. 24 can be divided by 6, you get 4. So you must use same number to divide up and down. So same number for this and this, and same number to divide this and this. Remember here I divide with 5. This number 35 and 25, I divided both top and bottom with 5. This one, I divided both top and bottom with 6. The highest factor, I use the highest factor, HCF, highest common factor, to divide both. So now what do I have in the numerator? I have 7 left here, times 1 is 7. What do I have in the denominator? I have 4 left. 4 times 5, I have 4 or 5 left in the denominator. 4 times 5, that's 20. So our answer will be 7 over 20. our answer will be 7 over 20. You get 4 marks for doing this, you go Shoko thing. You get 4 marks for doing this, something that is very easy that primary school can do. Now we move to question 9. Question 9 says factorize completely this expression, algebraic expression, 21a squared plus 28ab. We should factorize completely. So what we're going to do, we're going to look for the highest common factors between 21a squared and 28ab. The highest factor that can go to both. 7 is the highest one for the numbers. Because 7 can go to 21, 7 can go to 28, and is the highest of them all. Okay, so 7. Then there is another common factor. A is here. A squared means A times A. A squared means A times A. So there are 2 A's being multiplied here. And AB here, there's also A. So A is common to both here and here. So you take out the A that is common. You take it out. Then you open your bracket. What is left here, after you take 7 out, is not 21 minus 7, it's division. It's division. It's like you say 21 divided by 7. You get 3. You get 3. A squared divided by A, you get A. A squared divided by A, you get A left. So you write that one here. Plus, this plus, you write it here. Then you say 28 divided by this 7A, 28AB divided by 7A. 28 divided by 7, you get 4. AB divided by A, you get B, only B. Okay, you get only B. So our answer is as simple as this. 7A into 3A plus 4B. Finish, you write it down, you get your 2 marks if you're able to do this. You get your 2 marks if you're able to do this. Now let's go to the next one. This one is the one that is a little bit tricky. If you're not careful, you will think you cannot factorize it. You will lose confidence if you're not careful. So now let's take a look at it and see how we can do it. You can see x is squared, y is squared. So there's a difference between them. So we can do difference of 2 squared. Once you see something algebraic expression like this, one thing that should come to your mind is difference of 2 squared. One application is difference of 2 squared. Now, but this number 45 and 20 cannot be squared. Both of them cannot, they are not square numbers. So what we can do, we find the factor that is common to them, we take the factor out. Now you can see 5 is common to them because 45, 5 can divide 45, 9 will remain. And 20 divided by 5, 4 will remain. 4 is a square number, 9 that remains here is a square number. So we take the 5 that is common to both here and here out. There is no any other thing common to them. X and Y, they are not same, so they are not common to each other. So 20 and 25, what's common to 20 and 45 is 5. You take it out. What remains here, it becomes 4x squared. And what remains here, if you take 5 out, as in 45 divided by 5, you get 9 remaining, 9y squared. Now, if you take a look at this, to some, they will still feel, oh, but still, this is not a difference of 2 squared. It is. Because 4, you can square it. 4 means 2 squared. 4 means what? 2 squared. This 4 means 2 squared. 2 squared, and then x squared. 2 squared, x squared. Instead of writing them separately, you can put them together, 2x. Then you bracket both of them, you square them together. Instead of saying 2 square, s square, it's like you are a novice. It's like you are a JJC, you are a novice. In order to make it apparent, what you should do is just to say 2x, put them together, 2x, both of them square. Because it's 2 square, s square. Okay? Then minus, similarly, you do the same to this one. 9 is 3 square. 9 is what? 3 square. So instead of saying 3 square, y square, you say 3y, put both of them together, you square both of them together. Before you put your coarse bracket. This coarse bracket is showing that you are multiplying everything with 5. 5 is common to everything. Then now you can apply your difference of 2 square. You can see 2x square minus 3y square. Now we apply our difference of 2 square, which means 5 into 2x. In doing difference of 2 square, you just say 2x minus 3y in one bracket. You open another bracket, 2x plus 3y in another bracket. Once you reach to difference of 2 square, you don't do much. You just in one bracket, you use minus between the two algebraic expression, 2x minus 3y. In another bracket, you use positive plus for between the two algebraic expressions, you say 2x plus 3y. And then you swear, you put this 5 outside. Finish, this is your final answer. This is your final answer. If you're able to do this, you get 3 marks. You can see, you get 3 marks for being able to do this. Is that okay? So you, at this point, you can pause the video and then you try it and solve it and see if you're able to figure it out. Now let's go to the next question, which is question number 10. Which is question number 10. Now question number 10, we'll be given, this is a geometry. We have angle properties, what you call angle properties, so to say. Okay, now here we'll be given a geometry. You have 24 here in this angle. You have angle Y here. You have angle X here. You have 110 here. Now the question says point A, B, C, D, E, and F lie on a circle center O. Point A, B, C, D, E, and F. You see they all surround. There are 6 points. They all surround and they lie on the circle with center O. Okay, find the value of X and the value of Y. So the question did not waste time, just went straight by telling you to find the value of X and the value of Y. The value of X, we're going to use the first angle property, which says angle at the center is twice the angle at the circumference. Angle at the center is twice the angle at the circumference. Okay? For those of you who have done this in grade 9, and for those who have done this in grade 11, this or grade 10, I think grade 10 also you do this. So let's take a look at this. Angle at the center, where's the angle at the center? 110 is the angle at the center. They are standing on this arc AB. This 110 angle at the center is standing on which arc? AB, standing on arc AB. For any angle standing on the same arc, the angle at the center is twice the angle at the circumference. So we can use that formula. So you see, this angle X is on, although it's on the circumference, but it's as well standing on this arc. See, it's standing on the arc. See this? It's standing on this arc. Although X is on the circumference, angle X is on the circumference, it doesn't necessarily have to mean that we must draw the angle of the circumference to this place and to this place. It doesn't necessarily have to be like that. They can play with you. They can draw it to this direction. Okay, they can draw it to this direction like they've just done. So this is the same thing. Angle at the center equal twice the angle at the circumference. If they are standing on the same arc, AB. You can see this angle X is standing on which arc? Arc AB. And angle O is standing on the same arc AB. So when that happens, we apply the first angle property rule. So 2x, because we say angle at the center is twice the angle on this on the circumference. So 2 times the angle at the circumference equals to the angle at the center. So 2x equals to 110, x equals to 110 divided by 2, x equal to 55. So angle x is 55. Because angle at the center is twice whatever is here. Twice. Because 55 times 2 will give you angle at the center. Okay, I hope that is understood. Now let's see the second question. It says we should find y. We should find y. Okay. Angle standing on the same arc. You can look at this. Okay, let me use different color. Let's use different color to illustrate this other one. Now you can see this one, angle arc DE. This arc DE. This arc, you can see this angle 24 is standing on this arc DE, right? Is an angle on the circumference. Is an angle on the circumference. This angle is on the circumference and is standing on this arc DE. Similarly, angle Y is on the circumference and is standing on arc DE. Angles standing on the same arc and angle of the circumference standing on the same arc are equal. Angle of the circumference standing on the same arc, this angle Y, which is at point C, this angle Y is also standing on the arc DE. And there's another angle property rule that says that angle of the circumference standing on the same arc are equal. if they are both on the circumference, both angles are on the circumference, and they are both standing on the same arc, they will be equal. So it means y equal to 24. You don't need to solve anything. It means y equal to 24. It means y equal to 24. And that gives us our 2 marks. Okay, we wrote the rule here. Say for arc DE, angle of the circumference standing on the same arc are equal. Any angle on the circumference, if they are both standing on the same arc, even if there are 3 or 4 angles standing on the circumference and they are standing on the same arc, then they will be equal. They will have the same value. Okay, so let's move to the next question. I think you repeated that twice. Okay, we've done this already. Let's move to question 11. Question 11. Okay, here is question 11. We have a speed time graph. We have a speed time graph. Okay, and this journey starts from, you can see, from 6 to 12 and then straight to this way. So this is a speed time graph. We say the diagram shows the speed time graph for 90 seconds of a journey. For 90 seconds, you can see the time is 90 seconds. For 90 seconds of the journey. Calculate the total distance traveled during this 90 seconds. This is the advantage for those who are doing physics. This is a big advantage for you. It's in math and it's in physics. Okay, so now let's take a look at this quickly. Anytime they ask us to calculate the total distance traveled in a speed time graph, we're going to calculate the area under the graph. We're going to calculate what? Area under the graph. Sometimes we can break it into, I broke it into 2. Okay, you're going to calculate the area of this shape, the whole of this shape. It's called area under the graph. Okay, I broke it into 2, A and B. You can break it into 3. For those who are not very familiar with trapezium, you can break it into 3. So meaning you have A here, which is a rectangle. You have B, which is a triangle. We have C, which is a rectangle. So, but for us, we just did only here, which is a trapezium, plus here, which is a rectangle. Now, what we did for this trapezium, you can see this is the long length. This is the long length from 0. If you're moving up from this 0 origin, if you're moving up from 0 to what? To 12. The long length is 12. The short length is 6. From 0 here to 6. Okay, this is the height, this way. The height is 30. You can see it's 30. Okay, it's like you rotate this trapezium so that you can see it clearly. You can rotate it and draw it the way you want. Okay, so you can rotate this. This is the height. This vertical one is the height. And is what? 30. Okay, the two lengths are 6 and 12. So we just substitute those values into the area of trapezium by saying area of trapezium equals to half into A plus B times H. So half into A is 6 plus 12 multiplied by 30, which is the height. So half 6 plus 12 is 18. Half of 18 is 9. 9 times 30 will give you 270. 9 times 30 will give us 270. Okay, that's how we got 270 for the trapezium. Now let's find the area of the rectangle. This big rectangle. B, shape B. Shape B from 30 to 90 is 60. So this length is 60 from 30. Don't use 90 because here is 90. Remember, you are not using the whole length. You are starting from here. You are starting from 30. So 90 minus 30 is 60. So this length here is 30, while this way is 12. So you're going to say 60 times 12. That's the area of the rectangle. 60 times 12. So we say the area B is 60 times 12, which is 720. So the total distance traveled equal to the total area, which is 270 plus 720, which will give us 990 meters. Okay, so this is the total distance traveled. So this is how we calculate distance in a speed time graph. We just calculate area under the graph. We calculate area under the graph. We get the total distance traveled. Now let's move to the next question, question 13. Have we jumped? Question, okay, we need to jump. I think we delay very. You skip one, please. Okay, question 30. Okay, let's do 30 and see if we see question 12. Question 30 will be given, you can see this is the diameter. Why? How do we know they put a dot here? Telling you this is the center of the circle. Okay, this is the diameter, and any angle of the circumference, standard of the diameter is 90 degrees. So angle C is 90 degrees. This angle C is 90 degrees. Any angle is also angle property, one of the angle properties. Any angle of the diameter, any angle of the circumference, standard of the diameter is standing. You can see this angle C is standing on this diameter. Any angle of the circumference, standing on the diameter is 90 degrees. So here is 90 degrees. Okay, anyway, that's not the big deal. The big deal is you have a triangle here, a right angle triangle here. You have another similar one, small one, also a right angle triangle here. ABE is a small right angle triangle, and ACD is a bigger right angle triangle, all standing in half of the circle, all on the half of the circle. Okay? Okay. Now let's see. Yeah, let's zoom in so we can see clearer. Now let's see. C lie on a circle with diameter AD. It says C lie on a circle which I've already explained. C lie on a circle with diameter AD. Okay. Now B lie on AC. B is on AC. Look at B. B is on AC. You know this AC. B is on it. B is on AC. Okay. Now, and B is on AC and E lies on AD. E lies on, look at E, is lying on AD, right? Such that BE is parallel to CD, These two lines are parallel, okay? Now I say work out the radius of the circle. Work out the radius of the circle. I think we just find the diameter and then we divide by 2. We just find this diameter and we divide by 2. And to do that, the first thing we're going to do is to find the scale factor. You can see this base of this triangle has been given 80 centimeter. The base of the smaller triangle is 30.5. So we use these two bases to find the scale factor. This is similarity, okay? So angle ACD is similar to angle ABE. So we find the K, the scale factor, using CD and BE. So scale factor is the bigger one, CD, the bigger length, this one, CD, divided by the smaller one, which is BE. So 80 divided by 30.5, which will give us 1.33. So our scale factor K is 1.33. Now AC equals to, now let's find AC, since we know the scale factor. AC will be what? AC will be AB times the scale factor. We multiply this 21 times 1.33, we get the whole of this AC. We get the whole of AC. And once we get AC, we already know CD. We can use Pythagoras theory to find CD. This is a right angle triangle. We use Pythagoras theory to find AD, since this is a right angle triangle. This triangle is a right angle triangle. First, let's find AC. Since we know the scale factor, we multiply 21 times the scale factor, which is 1.33. We get AC. We get the whole length here. So let's take a look at that. We say AC, which is that whole length, is equal to AB times K, 21 times 1.33. That gives us 27.9. So now we know that we've written whatever we need to write. You can read. Now, that once we know that this place is 27.9, we know here is 27.9. Once we know that, the whole of AC is 27.9. So we can use Pythagoras theory by saying 27.9 square plus 80 square equals to AD square. Okay, let's use Pythagoras theory to do that. So AD square is equal to AC square plus CD square. So AD square equals to 27.9 square plus 80 square. So AD square is equal to 1,102.41. Then to find AD, just take the square root of both sides. Then you get 33.2. AD is 33. That's the diameter. Remember, they asked us to calculate radius, not the diameter. But you have to get the diameter first in this regard. So once you get this diameter, 33.2, to get radius, you just divide it by 2. Radius is diameter divided by 2, which is 33.2 divided by 2, you get 16.6. That's how we got the radius to be 60.6. You get 5 marks if you're able, because there are a lot of reasoning, a lot of critical thinking in this question. So if you're able to do it, you're going to get 5 marks for that question. Okay, now let's move to the next question. Okay, I think question 12 was skipped. However, it's okay. I think it's not going to be a big deal. Now let's go to question 14. We have 14a, f of x equals to 4x plus 3. G of x equals to 5x minus 4. And then f g of x is 20x plus p. Find the value of p. Find it. Okay, they've given you the f g of x. So what the first thing you do for us is to calculate the f g of x first on our own. Okay, then we compare with what they gave us. We calculate the f g of x. Okay, f g of x means put g of x inside f of x. Means put g of x 5x minus 4. You're going to put 5x minus 4 inside to replace x. You're going to put substitute 5x minus 4 to replace x here. So I'm going to write 4, then I'll open bracket, big bracket. I'll put 5x minus 4 in place of this x, because you're going to substitute g of x and put it inside f of x. Put it to replace x inside f of x. So anywhere I see x for function is very easy. Anywhere I see this whole g of x, 5x minus 4, I'll substitute it to replace x here. So I'll write this 4 out. I'll open big bracket and big space for this x, because I'm going to put the whole of g of x inside this place to replace x, then plus 3. Okay? So remember it's 5x minus 4. So in place of x, in place of this x, I put this 5x minus 4. So now I will expand. 4 times 5x, I get 20x. 4 times negative 4, I get negative 16. Then plus this 3. So 20x, negative 60 plus 3, you get negative 13. Remember that. Negative 16, it's like you're owing $16. And if you pay $3, you're still owing $30. Okay, so your answer becomes 20x minus 30. Now remember, they've already solved it. They say it's equal to this. Find p. So you compare it, you do comparison. You compare this one with the one you solved. You compare them. You can see they have 20x, we have 20x. They now say plus p, we had minus 13. They say find out p, so p is negative 13. Because when you compare, p will be what? Negative 13. This p will be negative 13. So your answer is negative 13 for p. Okay, you get 2 marks if you're able to do that. Now let's move on to the next one. The B part of the question says, h of x is equal to 5x minus 1. H of x equals to 5x minus 1 over 3. Now find the h inverse of x, meaning they want us to calculate the inverse of this function. So we also know how to do inverse function, right? We know how to do the inverse function, right? We know how to do function, right? Okay, now what we do, you say replace h of s with y. You say let h of s equal to y. So h of s equals to 5x minus 1 over 3. 5x minus 1 over 3. So you say y equals to 5x minus 1 over 3. The next is to interchange x and y. After you replace h of s with y, the next step is to interchange the position of x and y. This place, I put y here, I bring the s, I put it here. Interchange their position. So it becomes x equals to 5y minus 1 over 3. The next is to cross multiply and make y the subject. So if I cross multiply, I will have 3 times x. It becomes 3x. Like cross multiply. What is here, multiply with what is here. Okay? Cross multiply because of equal to. Equality sign. Okay? So if you cross multiply, here becomes 3 times x, I get 3x, equal to 5y minus 1. And then once you've done this, you make y the subject. To make y the subject, first move this minus 1 to the left. You know, when it comes here, it becomes plus 1. If you cross the equality sign, it becomes plus 1. So it becomes 3x plus 1 equal to 5y. 3x plus 1 equal to 5y. So the next thing to do is to divide both sides by 5 in order to get y. Divide here by 5, divide here by 5. So y will be equal to 3x plus 1 over 5. Now you can see this y is now absolutely different from your y assumption you made. So it means this is the inverse. It means this is the inverse. So y now, this your y is now the inverse function. So you say your inverse function, h inverse of x is equals to 3x plus 1 over 5. Okay? You're able to do it, you get 3 marks. If you're able to do it, you get 3 marks. Now let's move to the next question, question 15. Question 15 says we have a tangential line that touches a circle at point Q. Okay? That touches the circle at point Q. And anytime you have a tangent and an angle x on the minor segment, this is a minor segment, is equal to any angle of the circumference on the major segment. So if here is x, this place will also be x. And since they say here is same as here, if here is x, here will be x as well, okay? So I think this question just wants some geometrical explanation. It doesn't really need you to solve the explanation I've just given. Now you say P, R, and Q are points on a circle. P, R, and Q. P, R, and Q, they are points on a circle. Okay? Now, AB is a tangent to the circle at Q. I've already showed that AB, this line AB, is a tangent to the circle at point Q. Okay? Okay. Now we say QR bisect angle PQB. QR bisect angle PQB. See this PQB, this QR cut into equal parts. If that is true, if here is S, here should be X. If that is true, if here is X, here should be X, because you're saying that this QR is a bisector of this PQB. So here is X, here should be X. Okay? An angle on the minor segment with a tangent is equal to angle of the circumference on the major segment. So here is also X. So which means this place is same as this place. Okay, so this is isosceles triangle. This triangle PQR is isosceles. It's an isosceles triangle. Now let's see what they want us to talk about. Now angle BQR equal to X and X is less than 60. Use this information to show that triangle PQR is an isosceles triangle. You see, I've not even read that now. Before I could tell. Use this information to show that it's an isosceles triangle. So we already say RQP is X and QR bisect PQB. So if you bisect, it means if you say QR bisect, if you say this QR bisect PQB, then if here is X, here should also be X. So you can say PQR is also X. And go PQR is also X. That's one. Then another thing you can say, you say any angle on the made by the tangent to a circle on the minor segment is equal to angle of the circumference on the major segment. Okay, this side is the major segment. This whole side is the major segment. Any angle of the circumference. So which means here is also X. If here is X, here is X, the base of the triangles are equal. If they are equal, it means this is an isosceles triangle. Okay? So these are the geometric statements you make, and you get your marks. Let's go to question 16. M is inversely proportional to to the square of p minus 1. M is inversely proportional to the square of p minus 1. When p is equal to 4 and m equal to 5, find m when p is equal to 6. Okay, this is just a proportion or variation. Okay, so the first thing we say m is inversely, you write m, you write the symbol of variation to 1 over, because inverse, since you say it's inversely, once you say it's inversely proportional, then it will be 1 over p minus 1 squared, because they say the square of it. P minus 1, 1 over p minus 1 square, you square it. Then you remove the symbol of variation, you put the constant of variation k. So m equal to k over, k times 1 is k. That's why k replace 1, k times 1. You see, you remove the symbol of variation, you put the, once you introduce equal to, you put the constant of variation. It becomes k times 1, which is k over p minus 1 squared. Now we will substitute the value. P was 4, m was 5. So m is 5, I put 5 here. 5 equal to k over 4, p is 4, 4 minus 1 squared. 4 minus 1 is 3, 3 squared is 9. So 5 equal to k over 9. 5 equal to k over 9. So we cross multiply to find k. So k equals to 5 times 9, which is 45. So our k is 45. Now I say we should find m. Find m if p is 6. So you come back to the same formula. We're going to find m. Okay, you say m equal to k over p minus 1 square. M equal to, remember k, we just found k to be 45. You put the value of k here. So you say m equal to 45 over 6, because they say p is now 6. Okay, 6 minus 1 squared. 6 minus 1 is 5. 5 squared is 25. So now we have m equal to 45 over 25. So 5 go here, 9, 5 go here, 5. So 9 divided by 5, I get 1.8. So either we write that 1.8, or if it's a null calculator, you can leave it like this. You can leave it like this, okay? 9 over 5. Or you say one whole number, you put in a mixed number, one whole number 4 over 5. You leave it. Because if you are not allowed to use calculator, you cannot have it decimal like this. So you leave your answer as 9 over 5, or you leave your answer as a mixed number, which is 1 over 4 over 5. Okay, let's move on to the next question. Question 17. Now let's take a look at question 17. Question 17 is a bit of vectors and so on and so forth. Now let's take a look at what they've given us. 17a, we say m is equal to 5 and 7, 5, 7. Now the first question says 5, 3m. This is easy. They give you m to be 5 and 7. 3m is just use 3 to multiply this whole thing. So 3 times 5, you get 15. And 3 times 7, you get 21. So the answer is 50, 21. That's the column vector. You get 1 mark. It's easy, so that's why it's 1 mark. Now you'll be given VW equal to 10 minus 24. Find the modulus of VW. Modulus means, you know, this one represents x. You know, this one means x. And the bottom one means y. This bottom y 24, negative 24 means y. So what we should do is to square. Say to find the modulus or the magnitude, you say square root is equal to square root 10 square minus 24 square. This minus 24 you have to put in a bracket. If you square it, you get a positive number. 10 square gives you 100. 20 minus 24 square gives you 576. You add them together, you get 676. You find the square root, you get 26. So the modulus will be 26. And that's, you get 2 marks if you're able to do that. Now let's go to the vector question, the big part of vector. So here they've given us a parallelogram, okay, A, B, C, O, or O, A, we start from O. O is the origin, we start from O. O, A, B, C. O, A, B, C is a parallelogram. O is P, this one, This vector OA is P, and vector OC is Q. Vector OC is Q. E is the midpoint. E is the midpoint on AB. E is a point, not midpoint. I was wondering, how can here be midpoint? E is a point on AB such that AE to ratio EB is ratio 3 to 1. Okay, what it means is that 3 of this equivalent 1 of this, meaning you get 3 of this to be equal to this one. So meaning the total will be 4. Total will be 4. Here is ratio 1, while here is ratio 3. Altogether, AB will be 4, the total ratio. Okay, sum of ratio will be 3 plus 1, which is 4. And then we find AE. We're going to find AE, which is 3 over 4 of the whole of this vector. Now, what is vector AB? Since it's going in the same direction as OC, is also Q. Vector, in vector geometry, this line is going this direction, and this one is also going this direction. They are equal. So here will also be Q. Here will also be vector Q. The whole AB. The whole of AB is vector Q. However, what is AE? We have to find AE because we probably will be told to find OE. So we have to find AE first. AE is 3 over 4, ratio 3 out of 4 of AB. So you say 3 over 4 of AB. AE, from here, this journey here to here, is 3 over 4 of the whole of the journey of AB. It's 3 out of 4. It's like fraction. 3 over 4 of the whole journey. Okay, that's the meaning of AE. And we know the whole journey is just Q. The vector is Q. So you just write AE as 3 over 4Q. Now, the next question, what they want us to find is find OE. OE, this from origin. Find this journey all the way from origin to this place. We should find this one. We should find this one. That's what they want us to find. Find OE. So in vector geometry, this is easy. To get from here to here is here plus here. This journey, this plus this, right? To find this one. And we already know AE is 3 over 4, 3 over 4, 3 over 4 of Q. AE is 3 over 4 Q. A is 3 over 4Q. That's what we calculated first. So to find the whole journey, OC is equal to OA plus AE. So OC equals to P. Why is it P? Because OA is P. To find to find OE, it means you have to move from here to here and then to here. Finish. Just add the vectors. So OA is P. OA is letter P. OA is what? Letter P. So we just go to say P plus 3 over 4Q. That's it. It's as easy as that. P plus 3 over 4Q. And once you do that, you just write the answer. You get 2 marks. Finish. Okay, let's go to the next question. Question 18. Okay, they say the perimeter P is equals to 2 perimeter. Okay, sorry. Perimeter P is equal to 2e to W plus H. Okay, it's just a formula for perimeter. W is 12 and H is 4. Right? Correct to the nearest whole number. Both of them correct to the nearest whole number. Work out the upper bound for the value of P, the upper bound. Okay, so what we're going to do is to find the upper bound of each of the number 12. Number 12. Okay, let me use a color less conspicuous. Let's find the upper bound and lower bound of 12, upper bound and lower bound of 4. So for 12, the upper bound is 12.5 and the lower bound is 11.5. For the height, of 4, the upper bound is 4.5, the lower bound is 3.5. Now, since it's an addition and they're asking us to calculate upper bound, okay, we just add the upper and upper. We just add upper bound for addition. So the perimeter for upper bound is equal, this 2 is a scalar number. You don't need to do anything to this 2. You open the width, you use the upper bound of the width, which is 12.5, this one, plus the upper bound of the height, which is 4.5. So 12.5 plus 4.5, you get 17. 17 multiplied by 2, you get 34. So that's how this one is 34. The upper bound of the perimeter is 34. You get 2 marks if you're able to do that. Now let's go to, this is mensuration. This is mensuration. Let's take a look at this mensuration question. Here we've laid down some steps. It says the diagram shows cuboid A, B, C, D, E, F, G, H. Here you see A, B, C, D, E, F, G, H. Okay? Of length 20 centimeters. So you can see the length 20 centimeters. And width 5.5 centimeters. See the width of this cuboid, 5.5 centimeters. The volume of the cuboid is 495 centimeter cube. They've given us the volume, so we can calculate what? The height. Because we know the volume, we know the width, we know the length. Only the height we don't know. So since we've been given the volume, we can easily find the height. Okay, before we, is find the angle between line AG, this long from the bottom here to the top other corner of the cuboid. Is a very long way. Okay, say we should find the angle between the line AG, which we've drawn the line, and the base of the cuboid ABCD, and the base ABCD. Okay, so the first thing we do is to find this small diameter. There's a diameter, this diameter for the base ABCD. Let's find the diameter for the base ABCD. There's a diameter here. We have to, first of all, find. So, which means we can redraw this line ADC as a right angle triangle. We can draw it out. Okay? Okay, but before we do all this calculation, let's find the height of the cuboid. Because you're going to need it later. The height of the cuboid is, remember volume formula. Volume is length times width times height. So you write the volume down, equal to 20 for length times 5.5 times h. You multiply this, you get 110. Then to find h, you make it the subject. H is 495 divided by 110. You get 4.5. So our height is 4.5 centimeters. So we just do it. Even if they didn't ask you to do it, you're going to need it. You just do it and keep it in a corner quickly. And then step 2, like I said, you bring out this right angle triangle. You calculate this diameter, which is the hypotenuse. This diameter AC is the hypotenuse now. And here is your DC. Look at the DC, look at the A. So here is 20, here is 5.5. Is it Pythagoras theory? You find this longest side, the hypotenuse side. So when we do that, it becomes AC squared is equal to 20 squared plus 5.5 squared. AC squared equal to 20 squared is 400, 5.5 squared gives 30.25. AC squared you get 430.25, and you find the square root of both sides, you get AC to be 20.7. So that diameter, or the diagonal, I say diameter, sorry, I mean to say diagonal all the while. That diagonal is now 20.7. Now that diagonal becomes the base for another triangle. It becomes the base, look at it, the base for another triangle. So we're going to draw another triangle, ACG. We're going to draw it again, ACG, as another right angle triangle. I hope I showed it. Yes, ACG. The diagonal we drew just now is now the base. Is now the base. And this is the angle between the diagonal, between this base, the whole base, and this line AG. So this is the angle. This small angle is the angle they ask us to calculate. Okay, is the angle the question wants us to calculate, this angle. Here is the height. You see why I say we needed to calculate the height? We see this is the height of the cuboid. Now we are needing it, right? If we did do it, we at this point we'll go back to do it again. So here is the height. We write it here, 4.5. And we remember we already calculated this diagonal, which has become a base now, AC, 20.7. Okay? So this is angle theta you're looking for. Opposite over, this is a right angle triangle. This is a right angle triangle. Opposite over adjacent is tan. So we're going to use tan theta. Tan theta is equals to 4.5 over 20.7. Tan theta, you divide this, you get 0.21739. Theta equals to the tan inverse of this value, and then you get the angle to be 12.2. You get 5 marks, you're able to do this. 5 marks. It's easy, everything is easy, just for you to understand the rules and read every question, and thou shall not be scared. Many students fail because they're scared of questions, they're not composed, they're so scared. So the first rule in mathematics, thou shall not be scared. Just be brave, do a lot of work, that will give you that level of confidence. Okay, now let's see the question 20. Okay, let's quickly try and finish the paper. It said the curve y equal to x squared minus 2x plus 1 is drawn on a grid. Now a line is drawn on the same grid. Now the point of intersection of the line and the curve are used to solve the equation x squared minus 7x plus 5 equal to 0. Now find the equation of the line in the form of y equal to mx plus c. Okay, so we're going to see the difference between the original one, this original one, and the eventual equation. We're going to see the difference, right? Here we have minus 2x, here we have minus 7x. So what's the difference? If we subtract them, we say minus 2x minus 7x, you get 5x. You get 5x, right? The difference between them, you say this one minus this one. I get 5x. Why? Because here I will say minus 2x. Because this x squared, this x squared, if you minus them, is equal to 0. So you just say minus 2x minus minus. Why do I say minus minus? Because you are subtracting, and this one is already negative 7x. This minus is a subtraction. So minus 2x minus 7x, that will give you plus here. Because minus 2x plus 7x equals to 5x. Right? Then you come here, you say 1 minus 5. 1 minus 5. You get negative 4. So our equation, the equation of the line, which is in the form of y equal to mx plus c equals to y equals to 5x minus 4. Finish. You see, it's just 1 mark. It tells you it's not a big deal. It tells you it's not a big deal. Because I wrote the first equation, I wrote the second equation, then I subtract. Because you find the difference. If you subtract this from this, you get y. Y is here, there's no y here, you get y here. Subtract this from this, you get 0. Minus 2x minus 7x, you get 5x. 1 minus 5, you get minus 4. This is how we get the equation. You get 1 mark. We move on to question 20, whatever. And let's see, 21, right? Expand and simplify. This is easy. They give you x plus 3 in one bracket. They open another bracket, x minus 5. They open a third bracket, 3x minus 1. What you do the first two first. You do the first two, you expand this one first. So I will say x plus 3 in one bracket, x minus 5 in another bracket. I'll do this one first. The result, what I get, I will now expand it with the third one. So I will just say x times x, I get x squared. X times minus 5, I get minus 5x. Then 3 times x, I get 3x. 3 times minus 5, I get minus 15. So this simplified to x squared. Minus 5 plus 3x, it becomes minus 2x minus 15. So this is the result I get. I'm going to take this result to expand with the third one. I'm going to take this result and expand it with the third one. Okay? So here, we write the result. Step 2. We say x squared minus 2x minus 15 into close the bracket, open another bracket, 3x minus 1. So I'm going to take this one to multiply the whole of this 3 times, and then I'll take this minus 1 to multiply also the whole of this 3 times. So at the end of the day, I will get it 6 times in my first expansion. I will get it 6 times. So I take 3x to multiply s squared. I'll get 3x cubed. 3x times s squared, I get 3s cubed. Why? X times s to the power of 2 is s to the power of 3. This 3 times 1, there's 1 here, is 3. So you get 3x cubed. Then you take this one, 3 times this, you get minus 6s squared. 3x times minus 2x, you get minus 6s squared. Then 3x minus times minus 15, you get minus 45x. So I'm done using 3 to multiply the whole of this 3. I'm going to take minus 1. Minus 1 times s squared, I get minus s squared. Minus 1 times minus 2x, I'll get plus. You know, minus times minus is plus. If you make mistake in the signs, you're going to fail. Minus 1 times minus 2x, I'm going to get plus 2x. Then minus 1 times minus 15, I'm going to get positive 15. So now that I get that, I'll collect like terms. 3s cubed, there's no any other power 3. So I just write 3s cubed down. Minus, I have negative 6s squared. I have another minus s squared. So it becomes negative 6s squared minus s squared. I'm collecting like terms now. There, power 1 minus 45 plus 2x. Minus 45 plus 2x. Then plus the one that doesn't have x, 15. So you now say, you write this one down, 3s cubed. Then you deal with this together, minus 2s squared minus s squared will give you minus 7. It's like 6 chocolate, you are owing 6 chocolate, and you are owing another person. Let's say s squared is chocolate. You are another person wants chocolate, it becomes 7 chocolate you are owing, minus 7s squared. Then minus 45 plus 2. You are owing 45, you pay 2. Minus 45x plus 2x, you're going to get minus 43x. Then plus 50. 50 doesn't have any other number. This is your solution. You write your solution here, you get 3 marks if you're able to do that. Let's move to the next question. Question 22. Oh, now you remember question 12, the one I said we skipped. They didn't scan. Okay, now we have the question 12 here. Okay, let's do the question 12 before we move to question 23 or so, or 22. Okay, sorry about that. That is still in the paper. Now let's take a look at question 12. Is it Gamma records, is it Gamma? I don't know. Gemma records the times in seconds, taken for a group of students and a group of adults to complete a puzzle. The box and whiskers plot shows information about the times taken for the children to complete the puzzle. Okay, this is for children. This is the minimum value, this is the highest value. This is the lower quartile. This one is the lower quartile. This is the upper quartile. This is the medium. Media. Okay? Okay. For adults, they didn't give, I think we drew this one. They will give us information. Find the interquartile range of the times taken for the children to complete the puzzle. Interquartile range is the upper quartile minus lower quartile. Interquartile range is upper quartile. Where is upper quartile? This place. Q3 minus lower quartile. This place. So you have to read this one down and get the value. What value is here? For Q3, I think it's 70 something. Right? 70. It's 70. This is 70. Because here is 60, here is 80. So this halfway is 70. And then the lower quartile you read for children, you know. For children. You read the lower quartile down, read this one down here. What value? 48. The one before 50. The box before 50. The mark before 50. That's 48. So interquartile range is 70 minus 48, you get 22. You get 2 marks if you're able to do that. Now the B part of the question says, the table shows the information about times in seconds taken for the adult to complete the puzzle. The minimum value should be 28. The lower quarter is 42, the medium is 58, upper quarter is 70, the maximum is 75. So you go to, on the grid, draw the box whiskers plot for the adult. You do that, you get another 2 marks. They give you the value. They say this value is, okay, 28 minimum. Trace 28, you draw the line. You draw a line here. The lower quarter is 42. You trace 42, you draw a line for the lower quarter. The median is 58. Trace 58. Here is 60. Here is 58. Draw a line here. The upper quarter is 70. Upper quarter is 70. Draw a line on the 70. And the maximum is 75. So you draw a line of 75. Then you join, you know how to draw the box and whisker, you join everything together. You join everything together, and then you get your box and whisker for the adult. You do that correctly, you get 2 marks for doing that, okay? Say done on the grid. I wrote here done on the grid so that you can get these 2 marks, okay? Okay, now we go to question 22, right, if I'm not mistaken. Okay, that's the end. I think this is the end of the paper. So with this, we come to the end of today's class. Thank you for joining us. Okay, thank you for joining us.